Hi, everybody. It's the second week of the new semester, and hopefully, you enjoyed what you learned last week about parallelograms because we're going to take that and we're going to go even further and do special parallelograms like rectangles and squares that you've known about forever, and rhombuses, which for some of you, that might be a new word. When you were little, you probably learned about it as diamond, but the better mathematical term for it is a rhombus. And the special thing about it is it has four congruent sides, kind of like a square but not as specific as a square, and we'll get to that in a little while. And then diagonals you learned about last week, and we just did a whole exploration on them. So get ready to apply what you learned about diagonals. First, we're going to look at the parallelogram family tree. This is a very weird family tree. Hope you enjoy it. Basically, there's a grandma parallelogram, has two kids, the rhombus and the rectangle. Those two kids, it gets kind of weird here, so don't get too caught up on the specifics. The rhombus and the rectangle, they fall in love, they get married, they have a baby, the square. Here's what's very special about this family is every single characteristic that one of the parents has, they automatically pass down to their kid. Like your parent has blue eyes, they automatically pass it down to you. So the parallelogram passes all of its features down to the rhombus and the rectangle. And the rhombus and the rectangle pass all of their features down to the square. Weird family, but here's how it works. Let's think about some of the characteristics that we learned about last week about parallelograms. Diagonals bisect each other. Yes, that's true for a parallelogram. If it's true for a parallelogram, it automatically passes it down to its kids, the rhombus and the rectangle, who automatically pass it down to its kid, the square. Opposite sides are parallel. Of course, that's one of the lyrics of the song. That's true for parallelograms, who automatically pass it down to its kids, rhombus and rectangle, who automatically pass it down to a square. So are opposite sides parallel in a square? Yes. Are opposite sides parallel in a rectangle? Yes. Are opposite sides parallel in a rhombus? Yes, because they're all special types of parallelograms and they're part of the parallelogram family. All right, opposite sides are congruent, opposite angles are congruent. Yes, those were all parallelogram features as well, which means automatically it's true for their children and grandchildren. All right, diagonals are congruent. No, that was not true for parallelograms. You can tell here, this is a long diagonal. This one's a little bit shorter. Not true for just any old parallelogram, but we just did a diagonals exploration and we learned it was true for rectangles. Those ones do have congruent diagonals. If it's true in a rectangle, then it's automatically true for its child, the square. All right, how about all four angles are right angles? This is actually one that you've known forever. Rectangles have all four angles are right angles, so automatically its child, the square, has four right angles also. All right, one more feature to explore. Diagonals are perpendicular. That was true in our rhombus exploration. So if it's true for a rhombus, it's automatically true for its child, the square, but it's not true for a rectangle. So that's how the family tree works. There's other features too that we could look at, but I thought that was just a good way to get you started. And hopefully you can see the relationship. If it's true for the parent, it's true for the kid, which means squares inherit lots of features because if it's true for either a rhombus or a rectangle, it's true for a square. So let's start by exploring squares. Here's the key. You've known a lot about squares ever since you were little kids in preschool. Don't forget that old knowledge. Let's add more to it. So if I tell you MA is 8 in a square, squares have four congruent sides. You've known that forever. All four sides have equal lengths. Don't forget about that just because we're learning new stuff. So if MA is 8, 8, 8, 8. The other thing you've known forever is these angles are right angles. So that's what part C is asking for, MAT, 90 degrees. You've known those forever, four equal sides, four 90-degree angles. Here's where some of the newer stuff comes in. HST, we just learned in our diagonals exploration, squares and rhombuses have diagonals that make 90-degree angles. So that's true. Then here's another new thing that you learned in your diagonal exploration. If HS is 2, diagonals bisect each other, so SA is 2, but squares and rectangles have diagonals that are congruent, so really all these little halves are 2. I didn't ask you for the little halves, though. I asked you for the whole HA. 2 plus 2 is 4. And the whole MT. 2 plus 2 is 4. All right, finally, this one really hasn't come up yet today, but here's another feature that's just good to know. This is true for any of the quadrilaterals that have symmetry. Rectangles don't actually have symmetry like you would think, but squares do. Rhombuses do too. So these angles, if you folded the square rhombus in half, that angle would get split into 2 equal parts. So in a square, it's a 90-degree angle, so it gets split into 45 and 45. That wasn't on our list of properties up above, but that's true. For a rhombus, it works like that. It's just not a 90-degree angle. Just because the diagonals are perpendicular doesn't mean that the angles in a rhombus are 90. That's just for squares and rectangles. So that's a feature that might come up sometimes, but it didn't come up on our list so far. Okay, for your homework that you're going to be doing, there's some of the problems that are just like working with side lengths and angle measures and the basic features. And then there's, of course, a couple problems that deal with algebra also. So some of the problems are like number 2, where I tell you this figure is a square, or this figure is a rectangle, or this figure is a rhombus, and then you apply the properties. So that's what happens for this one. I give you angle MBR. We just did a good exploration about diagonals where we learned in a rhombus that that's 90. So that tells you what equation to make. That angle is 90 degrees. So we'll solve that quick equation. Minus 13 divide by 11. X is 7. Okay, how does that help us find the length of our H? Well, we had to be given something else too. So we were given that MR is 6.2x. So that's weird. The expression was for MR, not for RH. But don't forget, rhombuses have 4 congruent sides. So if I plug that 7 in for MR, that's automatically going to tell me what all the side lengths are. So we do a quick 6.2 times 7 calculation. Let me see what that equals. 43.4. That means this side's 43.4, this side's 43.4, this side's 43.4. Just like a square, rhombus has 4 congruent sides. That's like the big idea of what a rhombus is. So don't forget about that feature. So RH, 43.4. Yes, it's a decimal. Yes, that's okay. So that's how we can apply the properties of a shape. The other type of algebra problem I'm going to give you is, what if I tell you it's just a plain old parallelogram and you make an equation and then you check and see if any of those features are true to see if it's more specific than just a parallelogram. So let's see what we know. PM is 8x minus 7. And then this is always tricky to label. I gave you PR. 11x plus 1. How is that helpful? Well, diagonals bisect each other, so both of those halves actually could be called 8x minus 7. And then I could add them up and get a total of 11x plus 1. Because the other thing that was given, I gave you AM is 5x plus 2, but I didn't give you any expression for the other half. So I think we want to use the pink expressions. I want to add up my two 8x minus 7s. And set it equal to 11x plus 1. We did a lot last week where I gave you expressions for the 2 halves and you set them equal to each other. This time you had to add up the 2 halves and set it equal to an expression for the length of the whole diagonal. So let's add it up. 8x and 8x, 16x. 7 and 7 is 14. All right, now we have an equation to solve. Minus 11x plus 14. I can tell that this is going to come out nicely. 5x equals 15. Yes, 15 is divisible by 5. You get 3. All right, we're going to have to do lots of plugging back in because we have a lot of stuff to check on. So 8 times 3 minus 7. 24 minus 7, 17. 17, 17. All right, here's what we need to check. I'm going to plug it in also for the 5x plus 2 and see if I get 17 there, which I do. 15 plus 2 is 17. So check that out. 17, 17, 17, 17. Diagonals are congruent. That makes it a rectangle because we already knew it was a parallelogram. And now we know that the diagonals are congruent. Parallelogram with congruent diagonals. Could it be more though? Could it be the rectangle's kid, the square? So we need more information to find that out. So I gave you one more thing. I gave you angle AMP. So we also need to plug the 3 in for that expression that was given. There's a lot going on in this problem. If that angle's 90 degrees, then it makes it a rectangle and a rhombus, which would make it a square. If it's not 90 degrees, then it's not a square. So let's find out. 29 times 3 minus 5. Oh, it's 82 degrees. Not a rhombus, not a square. So I'm going to say not a rhombus because diagonals are not perpendicular. Check out this symbol. I can go perpendicular, not. So that means it's just a rectangle. So we checked though. Every time it's a rectangle, you want to say, could it be a square? But then if it fails that criteria, then nope, it's just a rectangle. So that's how you can check. It was just, we were given that it was a parallelogram. Then we had to check, is it a rectangle or is it a rhombus? If it's both, then that makes it the child, the square. All right, let's practice a bunch of this and let me know what questions you have. And hopefully these characteristics will all start coming together and making more sense the more practice that we do. All right, see you in a minute. Bye.